everybody, this is a lesson on Chapter 10, Lesson 6, Samples and Populations. All right, first of all, we have 6 vocabulary terms. I'd like you to go ahead and click pause and highlight the keywords. Okay, for our first example, we have, they want you to identify the population in the sample. The students in a school would represent the total population, and the students in a math class would be your sample. For example, number 2 is asking you want to know the favorite extracurricular activity of students at your school. Determine whether each method will result in a random sample and explain your reasoning. Go ahead and click pause on your video and answer the question, and then hit play when you're ready to go. Okay, on letter A, you ask members of the school band. This is not a random sample. It's a specific group of people, so this is not a random sample. Letter B, you publish a survey in the school newspaper. Well, not all students read the school newspaper, so this is not a random sample. Letter C, you ask every 8th student who enters the school in the morning. This is a random sample. And letter D, you ask students in your class. It is a specific group, so it is not a random sample. Remember, a random sample is where each member of the population is likely to be selected. All right, for example, number 3, you want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? Go ahead and click pause on your video and then hit play when you're ready to go. Remember, an unbiased sample represents the whole population. The people are selected at random, and it is large enough to get accurate data. So 100 students at lunch is unbiased because it represents the whole population. The people are selected at random, and it is large enough. Letter B, all students in a marching band are not random. It would be considered a biased group. 100 seniors at random. Well, seniors don't represent the whole population, so they would be biased as well. Letter D, 4 random students in the hallway. It is not large enough to represent your population, so that would not be a biased sample. Or unbiased, I mean. All right. A new power plant is built outside of town. Residents are asked how they feel about the new power plant. Determine whether each conclusion is valid, and then explain. Go ahead and click pause, and then hit play when you're ready. A local radio show takes calls from 500 residents. The table shows the results. The radio station concludes that most of the residents oppose the new power plant. Does this show valid conclusion? The answer is no. Not everyone in the town may listen to that radio station, and also when people call into radio stations, they're usually against the survey, and so they might be more likely to call the radio show. All right. It's the same question about the power plant, but this one is saying a news reporter randomly surveys 2 residents outside a supermarket. The graph shows the results. The reporter concludes that the residents of the town are evenly divided in the new power plant. So 1 for, 1 against. Is it a valid conclusion? The answer is no, it is not, because the sample size is way too small. 2 people would not represent the total population of a town. All right, same question. You randomly survey 250 residents at a shopping mall. The table shows the results, and you conclude that there are about twice as many residents of the town against the new power plant than for the new power plant. So 32% said that they were for, 62% of the people you surveyed said they are against, and 6% don't know. So that is about double. It is a large enough sample, so this would be, yes, it would give you a good valid conclusion because the sample size is large enough and they're randomly selected. All right, for this one, I'd like you to watch me do this question. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school, and then they asking you to predict the number of students, we don't know the number, we'll use the letter N, in the school who watch one movie each week. So to use a proportion, we need to remember that a proportion is part over whole, and it will equal the other part over whole. And we have two sets of information. The first proportion is going to be about the survey, or the first fraction of your proportion, and the other one is going to represent the total in your school. All right, so on this first survey, we asked 75, that's our whole, and we're looking for one movie. That would be 21 out of 75 would say that they watched one movie. On the other section, there's 1,200 students in the school. We're trying to figure out the number, unknown number, who watched one movie. So we have our proportion set up. All we have to do now is use cross products, and we end up with 75N equals 25200, divide by 75, and we will find the number of students in the school is 336 who watch one movie per week out of the 1,200 students that go to the school. Okay, on the next one, go ahead and do this question on your own. Please hit pause right now and then hit play when you're ready to continue. All right, we're going to use a proportion. This time we're looking for 2 or more. We have 75 students that were surveyed, and 24 out of those 75 said they watched 2 or more movies. There's 1,200 students in the school, and we're trying to figure out the part that would watch 2 or more movies. Cross products will give us 75N will equal 28800, divide by 75, and we find out that there are 384 students who watch 2 or more movies out of the total 1,200 students.